places. Let us start. So consider if we have an integral like this. So it will be the sine 1 by z and the domain is z and of a mod of x plus mod of y equal to 1 is oriented positively as a simple closed curve. So we talk about it is a simple closed curve, then we have to find the value of an integral. So the closed curve will be like this. So this is a closed curve 1 1 1. Now we have to check its singularity. This expression is if f of z is equal to sine z 1 minus cos of z cube. So yes, it's a cos of z cube. So we need to find the singularity of this expression. So for that, the singularity of the f of z will be where 1 minus cos of z cube is 0. So when it becomes 0, if and only if the cos of z cube is 1. And when it be a 1? When it's a simple to solve it when z cube is equal to the 2k pi and k be an integer. So all the numbers, so put the value the k equal to 0, so it will be 0, 2 pi and 2 that plus minus and other. So all these except the 0 will lie outside here. So then the integral will be the 0. But then we need only a one singularity, which is z0, z equal to 0. So for the z equal to the 0, we have to find this integral. So to solve this integral, what we do, there's a lots of methods, but to solve this integral, when we have an expression like sine z 1 minus cos of z cube, we find the residue of f of z at z equal to 0. That will be the coefficient of 1 over z. Now plus z5 by 5 factorial minus z7 by 7 factorial, and cos of z will be 1 minus z square by 2 factorial plus z4 by 4 factorial minus. But now we have cos of z cube. So what will be that? Cos of z cube. That will be 1 minus z of 6 by 2 factorial plus z of 12 by 4 factorial minus z of 18 by 6 factorial plus and so on. Now to solve it, let's come to here and okay. So now use it in the expression as f of z is equal to sine of z 1 minus cos of z cube. So use these expressions here. So what will be? So it will be z minus z cube by 3 factorial plus z5 by 5 factorial minus z7 by 7 factorial and so on. So here will be 1 minus z6 by 2 factorial plus z12 by 4 factorial minus z18 by 6 factorial plus and so on. Now numerator will be the same, so we can write it like this z cube by 3 factorial and so on, or we use this term as well. So 5 factorial minus z7 by 7 factorial. and so on. Here will be minus and 1, 1 and 1 cancel out, and minus will be here. So that will be the positive, this will be the negative, and that will be the positive again. So it will be z square by 2 factorial minus z12 by 4 factorial, and it will be positive z18 by 6 factorial, and so on. Now, numerator once again be the same, so we can write it z cube by 3 factorial plus z5 by 5 factorial minus z7 by 7 factorial, and so on. So we can write here, we can just take a common here, that will be z6 by 2 factorial, and here will be 1, and here will be 2 factorial z6 by 4 factorial. So also here will be plus z2 factorial z18, that will be 12 6 factorial, and that will be negative here. In order to find the coefficient of a 1 by z, the terms that z raised power 6, z raised power 12 all have a higher order. So we need a sum of them. So how to solve it further? So let's take this side. 2 factorial over z6, and this will be the numerator will be the same, z minus z cube by 3 factorial plus z5 by 5 factorial minus z7 by 7 factorial, and so on. And we can write it like this, and that will be in the numerator we can write it like this, 1 minus, the minus will be the common from all the sides, so it will be 2 factorial z6 by 4 factorial minus 2 factorial z12 by 6 factorial, and plus, and so on. And here will be minus 1 raised power 1. I hope you have understood this. So once again, in order to find the coefficient of a 1 by z, check the values here. It will be, when we solve it by a binomial theorem, the order, the degree will be the higher than. So we have like this, z of 6, that will be z minus z cube by 3 factorial plus z5 by 5 factorial minus z7 by 7 factorial, and so on. And here will be 1, and that will be the plus this term, this whole term. So that will be the square in that will be like this. So these terms will have the higher order, and when they multiply with it, with this, whether z cube, whether any one of them, it's a very simple, but it takes a time. So in order to that, I am cutting this calculation here, and to find reach on this main conclusion, so which is that that will be like this. So here the z raised power 5 over 5 factorial is the only way to get the coefficient of a 1 by z. So what we get here, 2 factorial, and here will be the z of 6, and here will be z5 and 5 factorial. So it will be 2 over 5 factorial will be 120, and that will be 1 by z. So it will be 1 over 60. So the residue will be 1 over 60. That is a coefficient of a 1 over z. So the question is the value of an integral. So the integral will be 1 by 2 pi, and here will be, instead of this, we can write 60. So it will be residue of this will be 60. So we can solve it like this. Now 120 into 1 over 60. So that is 2. So the correct answer is 2. I hope you have understood. Now move to the second. In order to solve this question, so there's a one theorem. Let us first discuss the question. What question says that let u equal to z belongs to its a plane, the positive side of the plane, and the d be a disk where it's a imaginary part, and S be the set of all bijective analytical functions such that f of I equal to 0, then the value of a when the value of a sup of f belongs to that set, f of 4 pi is equal to 0, 1 by 4, 1 by 2, and it's 3 by 4 and 1 by 2 separately. Now, we know a one theorem regarding this, and the theorem is with map u, which is the imaginary part is like this, the upper side of the part, it maps to the disk, and disk is like this. So this part, when this part, the upper side of the part, map with the u onto the unit disk such that f of alpha equal to 0, alpha belongs to this u, are given by f of z is equal to e theta, ei theta, z minus alpha, z plus alpha, conjugate of alpha. Now, imagine if we have this set, if we have this function that f of u equal to 0 such that f of I equal to 0. So what will be the value of I? So it is it's a very simple, we can find it like this. F of z will be ei theta, and here will be, instead of alpha, we can write a z, we can write iota, z minus iota, z plus iota. So now what we have to find, that is f of 4i. F of 4i, it will be ei theta, and that will be 4i minus I, and that is 5i. So we can write it like this: ei theta 3 by 5. Now mod of f of 4i, that will be 3 by 5, and use the supremum f belongs to s, f of 4i, that will be 3 by 5. I hope you have understood, and this will be the answer. Thank you very much.